Hi everyone, my name is Kielminski, and for my final project, I designed a unit on solving systems of linear equations. This unit was designed for my Algebra 1 classes. The majority of those students are freshmen, although I will end up with some 10th and 11th graders, either from the introduction to algebra class they place into, or from ELL students who have transferred in with credits that don't line up with the building requirements. I teach in an upper middle class community where students typically do not struggle to obtain materials for school, access to the internet, or additional resources outside of school. I teach the co-taught sheltered EL section of Algebra 1, and I've also co-taught special education sections of Algebra 1 within LBS, where 30% of those students have an IEP. So I've really experienced a lot of different needs in my Algebra 1 classes, and I've found that differentiation really is required to best reach all of the students in all of my classes. This unit will cover three main objectives. The first being students will be able to solve a system of linear equations using any solving method. We're going to talk about three. Students will also be able to justify the number of solutions to a linear system using evidence from the equations. And then finally, students will be able to write a system of linear equations from a contextual situation. For my prescriptive strategy, I went with Gagne's 9 events of instruction. I've found that this is typically the way that my class goes without even thinking about it. So it was natural for me to kind of apply this to my unit. We've all seen this before. I highlighted step 4, 6, 7, and 8 as kind of a focus for me in making sure I go through that kind of cycle of presenting the content, asking the students to practice, providing feedback on that practice, and then assessing their performance after the feedback has been received. Specifically in this unit, solving systems is something that requires repetition. It's a skill that the students can only obtain if they try solving systems. And so I'm really going to make sure that I give them as much time as possible to practice all of those skills. And again, just highlighting that practice feedback assessment loop throughout my unit, making sure that I'm giving them all an opportunity to practice and then demonstrate their learning. I always try to recall prior learning. I think I'm going to emphasize that a little bit more in this redesign. It's something that kind of gets pushed back to the side a lot of the time. So I'm really going to focus on making sure to bring up that prior learning whenever I can. For my selected technology, I went with Desmos, which is kind of a two-pronged program online. Here I have a screenshot of the graphing calculator capabilities of Desmos. You can see on the left-hand side, you can type in any equation that you want. I typed into linear equations here. And then the graph shows up on the right. Desmos is a lot easier for the kids to use than the typical TI-84 graphing calculator. You can just pinch the screen to zoom in or zoom out, and you can move the window really easily. And if you highlight points of interest, it will tell you exactly where the location of that point is. So Desmos is definitely something that I've found the kids enjoy using more than their traditional TI-84 graphing calculator. The other piece of Desmos that's really cool is the activity builder side. And I found an activity that I want to use in this unit that I thought I would take a couple minutes to walk you through. So this is a activity that Desmos has on their site about systems. There's a little warm up here. Line zapper. So I'm going to type in the 0.02 and it will send a little current to that point and zap the line. And so the goal with this activity is for students to do that with systems. So for demonstration purposes, I found the solution, but students would do the work on a piece of paper, type in the intersection point, and hopefully it zaps both of the lines. So just a visual way of finding the solution to a system of equations. We have the first half of the answer, x equals 10. Again, just practicing the skill of finding the second piece of the solution. And this is 4 lines, and you have 3 zaps. So again, just challenging the students to think about intersection points and how best to use their 3 zaps. The point -11.8 gets 2 of the lines, and then it's up to them, to decide how they're going to get the other lines in this system. Flip the question a little bit. Another important piece of solving systems, given a point, which lines are included in that system? And then upping the ante a little bit with some hidden lines. But again, students would do the work on a piece of paper and hopefully come to the conclusion that 2, 8 is the intersection point, and there are both of the lines. It goes on then with a challenge problem that if students are finishing up the activity quickly, they can go there. And then we would end as a class on this reflection question. And even another challenge with a little bit more complicated equations for students who feel like they're ready for that. To get on Desmos, students will need their Chromebooks. Also, we're going to be creating a presentation towards the end of the unit on Google Slides. And I will also be assigning exit slips on GoFormative. The course of the unit will look like this. These first 4 days will be a pretty similar process of taking notes together, doing practice problems in class, checking those problems, and then assigning some homework problems for class or for that night. The 3 different solving methods, we're going to start with graphing on day 1, solving by substitution on day 2, and then solving by elimination on day 3. Day 4 is a really important conversation to have in saying, based on the system that you're given, which solving method makes the most sense, or which solving method is the most efficient method to use. So kind of a practice day on day 4. And then we would take a quiz just on those 3 solving methods on day 5. Day 6, we would take some notes on special solutions. So one solution to a system, infinitely many solutions, or no solution. And again, practice in class would follow, and then some homework problems to try on their own. Day 7 is a differentiation day for me, something that I really like doing in my classes. I would take the results of the quizzes from day 5, do some grouping based on those results, and make sure that students are getting whatever they need based on those quiz results. While they're not working with me in their groups, they're going to be working on that line zapper Desmos activity that I showed you. Day 8 is when we're going to introduce the context situations, which is a recall of prior learning because we've written 1 linear equation. So now we're just going to write the system of 2 linear equations from context. And then day 9 and 10 are going to be devoted to some small group presentations. On day 9, they will be given a contextual situation, and their job will be to create a presentation annotating that situation, choosing a solving method, doing the work, and then answering the question. On day 10, those groups would give their presentations, and we would do some generalized test review for the unit test on day 11. When it comes to differentiation, I mentioned briefly the quiz corrections day and making sure that based on those quiz results, students are getting what they need. I think in general, Desmos is a way to make solving systems more accessible to all students. It's a really efficient way to check your work and see if you're doing something correctly. And it also directs them pretty quickly back to their work if there's a mistake that needs to be fixed. There are some text-to-speech tools and translation applications that my students have been using in the past, and I think have been really helpful, especially for my English language learners to access the Algebra 1 material. And then something else that I thought of with the group presentation is that I could scaffold by providing the system from the context instead of asking the group to come up with it on their own, and then they could use the system to finish the presentation from there. The two handouts I created, one would be a really introductory handout that we would fill out very first thing on day 1, just introducing what a system is, how we solve it, and what a solution to a system means. And that's something that they would have access to for the rest of the unit to reference when they need it. I also created this graphic organizer for day 4, which method do I use? We would put some general guidelines to look for when it comes to using each solving method, and then practice with those systems at the bottom. For my sample student artifact, I created a Google Slides presentation that they would create on day 9. You can see I titled my presentation. I annotated the situation, so I did some highlighting. And then I did the work, I presented my work, and then I answered the question. And this would be something that the students would be expected to do. I would probably even give them some sort of template that they could then edit for their own presentations. My online digital content is going to be a shared Google Doc. I set it up as a calendar, so it's really quick to access whatever they need for whatever day they're looking for. I've included a couple things here. You can see I have the link to our digital Algebra 1 textbook, just for a general reference for anything. The introduction notes handout is linked at the very top of the calendar. I linked the graphic organizer on day 4, the line zapper activity on day 7, and then my sample presentation on day 9. And as we're going through the unit, I would include any other notes keys or extra videos or anything else that I think would be helpful for them to access on this one-stop shop for linear systems. I classified this unit as augmentation. The old technology, again, as I mentioned, is the TI-84. Kids really struggle with that, and they have a hard time persevering through figuring out what buttons to press to make what they need to happen. The Desmos technology is still a graphing calculator, but it comes with increased functionality for the students and also every other extra piece to it, especially the activity builder piece. To assess student learning, I would be doing daily homework checks the next day just to make sure that there was no glaring questions that needed to be addressed. I would also be able to check the Desmos activity builder progress and any other exit slip information that occurred during the unit. In terms of summative work, we have that quiz on day 5 and then a unit test at the end. And I would also be grading their group presentation on a rubric for points there. To assess the design of my unit, I would create a Google Forms survey that students would take on the last day of the unit after they finish their test. I would ask them to do 2 things. I would ask them to rate the learning activities on a scale of 1 to 5, and also open up the option for feedback on any of those specific activities. And then I would also ask them some open-ended questions, things like, if you would like to do a certain activity again, or if there is some sort of new activity that they would like to see incorporated in my class, any of those sorts of things would be on that survey as well. And that is my unit. Thank you so much for listening.